questions or you couldn't follow the subject something, try to raise your hand and I'll give a chance to ask your question. So any questions, feel free to ask. Okay. So I hope you are able to see my screen. Can you please confirm? Are you able to see my presentation?
Yes, we are.
Good. Good to go. So one second. So today, our major agenda will be like to understand like what exactly a data engineering is, data engineering, and what they do in a day-to-day basis as a data engineer, and what are the skills we need to become as a data engineer, and what exactly does the big data mean, and what exactly is Hadoop, and why should we learn these things to become a data engineer. So it's more of like an introduction session to the both the job role and also the technology related to that. So firstly, we always like the current one of the buzzwords we'll be listening to is big data. We'll be listening this big data analytics and processing, etc., etc. So this is a buzzword almost from 2 decades, not just from 1 decade. So what exactly is big data? So generally, what a data is, first question. So data is nothing but collection of information, right? But more of, instead of information, we should be using as the term collection of raw facts. So why we call as raw facts is that it, it's not necessarily that the whatever the data you collected should make sense just in the first look. Sometimes, like let's say a sensor device is sending some data and we are collecting that data. So because it is coming from a device, not necessarily right away we will understand the data. When you have an understanding about data or some insight from the data, then the data becomes information. But here it is like more of collection of raw facts. So but when we talk about big data, from the name itself it's so clear that definitely it is big in size. Let's say we just got some data set, okay, and we need to decide whether the given data set is big data or not. How does we decide the given data set is a big data or not? So for that, we need to majorly look with three parameters and we call them as characteristics of big data. So one is volume, another one is variety, and the other one is velocity. So like whenever we got some data set, if we need to decide whether the data set is big data or not, we should be checking with these three parameters. So now when we say volume, it's about the size. So the data set should be really huge size. But the question is how huge it should be. Like, will 10 GB make it as a huge size or 10 TB make it as a huge size? That's the question. But it should be of huge size. We'll come back to answer to that question. Then variety. So variety is about the format of the data. So the data format is one of the parameters which we look for to decide whether the given data set is big data or not. Then velocity. So velocity of data is like data per unit time. So that means, is your server getting 5 MB per second or is it like anything like 500 MB per second? So this is the amount of data received by a server, right? So that is the velocity, data per unit time. So these are the three parameters we should look into any given data set to decide whether it is big data or not. Now, so when we say it should be of huge size or a kind of format it needs, or it should be of lot of velocity. So now the question mark comes to what level? So how much is size will define it to be big data. So for that question, we need to understand one thing that around the year 2000 is when we got the term big data. So, but before to year 2000 also, there is lot of data, right? And that data is managed by various databases, right? DBs. But the thing is, what just happened after 2000 is that so there is a lot of innovation happening with respect to the chips, processors, and devices. I think around 2004, like that. So from 2000, there is a lot of digitalization just started, and then because of this digitalization, whatever the processes we have, they started turning into the web applications, and later on what added to them is mobile applications. So because of these changes, what just happened, so till before year 2000, the kind of data we will be having is like more of tabular kind of data, which we call it as like structured data. So here we need to understand one factor. So majorly, what are the different types of data we have? So we have three categories of data. So one is structured data, and the second one is semi-structured data, and the third one is unstructured data. So now when we say structured data, that means any given data set that can be expressed in the form of table. So expressed in the form of table, that is like structured data. So example formats of these files are like CSV files and TSVs. They're like more, much more. But these are few of the most common examples you'll find within the structured data. So you can think of an Excel sheet. So if you click on an Excel sheet and see, if you see it name, sometimes it will be like some the data.csv, the file name will be like, or data.tsv. So comma separated value or tab separated value. That is the format of the file. So these format files will be fall under the structured data category. Whereas semi-structured data is something which cannot be straight away expressed as table, but can be pre-processed and then can be converted as a table. So example to these things will be like the JSON files and the XML files. So if you are so new to the computer science, you might not have seen this JSON or XML file. Let's say, let's look at the few file format here. For an example, in second, let's take, mm, yeah. So in that, let's say a CSV file, and then, and also let's take a JSON file. So now when we say CSV file, let me take a proper example. Mm. So this is the file. If you could see here in this file, so you have something like family name, given name, and an ID that is keep on repeating here, right? At the same time, so this file can be straight away uploaded into a SQL database basically, so that the data can be converted into a table. So this is the structured data because it has a specific pattern and it has a proper way that can be expressed into a table. Whereas when you say JSON file, so here you have a pattern repeating, but not necessarily the file can be straight away uploaded into a server or something. So, but what we can do is we can extract the values from the file. This is an example for the JSON file. It's about the format. See, here also you have the first name, last name, and certain information regarding the person, and it's keep on repeating the pattern. So the data you have here and the data you have here is like same, but the thing is the way it is organized is what different basically. So so this data is like an example for the semi-structured data, the JSON files. Certain times the JSON files might look little more complex, so we use programming to process that data and then convert it into the table. So that's the reason it's called semi-structured, because it has a pattern within it but needs some processing. Then comes unstructured data. So unstructured data is something like cannot be expressed in the form of table. So examples for these are like you can think of like video files, audio files, and there are many other formats like certain log files, and so sensor data. So all these data files are like unstructured data because they cannot be expressed in the form of table. So why we are looking into this is specifically because you have a parameter to look at the format. So which category of data will become the big data is the one of the point we should look in. And what happened after the digitalization is that, so before to 2000, the most of the data you are having is like structured data, and then there is to some extent it's like more of like semi-structured data. Even though people tried to store the unstructured data, they never thought of processing. So one thing we should always think about is that, so whenever you think about data, two things you should be imagining. So one is storage, another one is processing. So two factors are important. So we store data not just to retrieve the previous transaction and look at it, but to process the data and get some insights from that particular data is like one of the important factor. So whenever we think about that, we should think about both the things. So even though we have stored the unstructured data before the year 2000, but it's more of storage only. To process it, we doesn't have the advanced tools or things like that. So, but after 2000, because of digitalization and even the infrastructure cost keep on decreasing. That means now we are easily able to accommodate 8 GB, 16 GB RAM into a mobile phone. But it wasn't like that when we were in a school age, or if you think about a decade back, it wasn't like that because even the infrastructure cost got reduced. So, because of all these factors, there is a huge data generation increase in data generation. But this increase in data generation is happening with respect to the size, with respect to the format. That means it is generating both the structured, semi-structured, and every format of data. At the same time, because so many people are using mobiles or web applications at the same time, it is creating to generate, see, if 10 people are using a phone in a second, it might generate 5 MB per second. But if 100 people are using the phone at the same time, then the application, then it would create 500 MB per second. So even the speed of the data, the velocity of the data is also continuously increasing in the real world. So now, so whenever a data set is difficult to handle with the existing databases, because the big data term itself came in the year 2000, right? So the definition is also came up at that point of time. That means before to year 2000, we have like certain standard databases, like you can consider SQL Server, which most of you know, and the data warehouse like SQL databases and the data warehouse mechanisms that we used. So we call them as traditional solutions basically. So whatever we had till then, so we call them as traditional solutions. So whenever the given data set becomes difficult to handle with the existing solutions or the traditional solutions, then that data set will be considered as big data. So when we say difficult means, so let's consider a SQL server here. So in an SQL server, for say, the maximum file size capacity is around 25 TB. So a single file can be of size of 25 TB. But let's say a lot of people are using your application and the data is continuously growing and your file size is getting to be somewhere around 35 TB. So, but the file is structured data only. See, SQL Server can only accommodate the tables and nothing else. That means it can accommodate only structured data. And if your files, the server capacity is 25 TB, and if you're getting the data of 35 TB, now here the problem is not with the format or not with the how much data is being generated in given time. That's not the problem. But the problem is the size of the file. Okay. So then this particular data set will become big data because of the volume, but not with the format or velocity. It's not with the variety or velocity. But now let's say you just got some 10 GB of video file and you need to make some face recognition. So this thing cannot be achieved with the SQL server. So, but here is the problem with the size. So 10 GB is not a problem. You can even store in a memory card, right? So in that case, this data is becoming big data because of the variety, not because of the size or not because of the velocity, but because of the variety of the data. And the other parameter is velocity. So to understand that, let's say we just launched a new application. So we thought of like some 300 users will be using per every given second. With that expectation, we bought a server whose capacity is like, let's say, this what are the usage of 300 users, it will generate some 50 MB per second. So we bought a server which has a capacity of 500 MB per second is our server capacity. So now what happened is the application is like extremely successful. So it's like more than 3000 users are using per second. So that would generate how much per se? It would generate some 500 MB per second. So that is the maximum limit of your server. But what just happened is it just got exceeded, and right now almost 6000 users are using per second. So now here the problem is not about the size of the data or the storage of the server, but about we call it as throughput. Throughput means the receiving capacity of a server. So the throughput is maximum of 500 MB per second, but here it is generating almost 1000 MB per second. Your server can store the data, it has the storage, but the problem is it doesn't have the ability to receive this amount of data. So here the data set becomes big data because of the velocity. So any given data set, even at least with one parameter, if it becomes difficult to handle with existing traditional solutions, then that data set is big data. So now the given data set can also have complications or the complexity with two parameters, or sometimes it might satisfy all the three parameters. That's okay, but it should be difficult with at least one parameter. Why? Because let's say um, you just got somewhere around some 100 GB of table data or structured data. So just to process or store this 100 GB data, you will not get some 20 servers, 30, like 30 servers and people do them, not like that. You can just have a single SQL server where you can store your data and do the things, right? So this doesn't make up the big data at all. So until unless it isn't complex with handling with existing mechanisms, so it isn't necessary to move to a big data kind of solution. But in current world, there is like a huge growth of big data. Let's just see a few examples for them. So with whatever we have discussed, you should be good with this slide. So I give you a moment, just go through this slide and ask me if you have any question. If you guys are good to go, like just look at this slide. You should have a basic understanding. So if you find anything as a question, just you can post to me, or you can just raise your hand and we can have the discussion. So next thing. So the characteristics of big data we discussed is like volume, variety, and velocity. And we have one more factor called veracity. So veracity is considered in certain data sets where the veracity is about the certainty of the data or trustworthiness of the data. Let's say you have a healthcare where there is some medical research going on, and you just got a lot of data sets to analyze the tumor within the patients. Now you need to identify a pattern within it. So for that, the data should be trustworthy, like it should be from a proper source, the patient records should be correct. So veracity is a factor where we consider the what is it a reliable source of data or not, from where we are getting it and all. But these are the key characteristics you will find in internet, the 3 V's, 4 V's, 5 V's, and even 10 V's people talk about. But majorly when you talk about with respect to deciding a data set to be big data, these are 3 V's are the major ones. And the next thing we always consider is veracity. Now, so a few of the real world examples you can consider with respect to volume is we have 500 million tweets a day. which is almost like 12 TB of data created every day. And considering variety of data, so it's like sensors, audio, video files. So clickstream data is something like, so whenever we go to a shopping website or any website which has the products and services, so let's consider the Amazon, Flipkart, anything. So now when you click on an item, so it is going to show you the suggested item, right? So how it is doing that? So, or it is saying like based on your recent search, these are the items. So there, every click of your item is actually recorded and then processed. So that the data that is collected by clicking on the items is like the clickstream data. Okay. These data will fall under like big data with respect to the variety. So all these things. And then velocity. So scrutinizing 5 million trade events every day to identify the fraud, basically. So you will have like having 5 million trade events a day is something okay to be handled with respect to storage, because it can be more of like structured data only. What you get with the trading events, it's not a challenge about the format. But if you see the velocity, why? Because trading happens in the peak hours, in the specific 1 hour or 2 hours, sometimes within a 15 minutes. The most of the trading happens at the peak hours. That means here, this is more of like you will have huge amount of data generated at a one given time window, basically. So that is with respect to velocity. And as we just discussed, the example of veracity is like patient records for research. It should be a reliable source with the evidence. So that means someone should be approving that data. So that's about veracity. So these are like the characteristics of big data. And one more interesting real world example will be like an aeroplane. So while an plane is flying, it generates almost 10 GB per second per engine. And a plane will have two engines and 5,000 sensors within it. So if you think about a 6 hour flight, so per each second, so this many seconds and all, so it is going to generate a huge amount of data. So 10 GB per second is like huge with the velocity. And because you have 5,000 sensors, you'll be getting different formats of data, like structured, semi-structured, unstructured. Like some data might be images, some data might be like a pressure or wind directions, latitudes, longitudes. So the data might be of different types and huge size. So this example satisfies all the three V's that we have. And in any given day, it generates this much amount of data in the Newark itself. So what if you consider the entire this is just a single flight or a single day we are considering of an airport. So both international and domestic across the globe, how much data it is being generated in a day. So what if we consider every other scenario, like let's say social media. So in social media, for every 60 seconds, this is the amount of data that is being generated. So a lot of tweets, lakhs of messages, millions of Insta messages, and more. So with all this, it is so clear that how the big data is being growing. So we just discussed, so this only put forward the things like with respect to the aviation and the social media. But what if you consider every other domain like manufacturing, banking, retail, and every other category? Now the biggest challenge is how to store all this huge amount of data and process it and analyze it. So now I do have a question for you guys. Why do we analyze data? Let me give you guys mic so that you can speak up. So why do we analyze data? Anyone? You can unmute yourself and give your point.
Yeah,
Why do we analyze data?
to take the right business decisions in the real time, we need to analyze this data so that we can get the insight to make the decisions.
Perfect, perfect. Yeah, that's very true. So we just store and process the data not just to have a basic analysis, but more of like we need to make the business decisions. So that helps in generating the profits. So now when we say about business decisions, sometimes it can be like selling a product, but sometimes it can be like more of giving customer experience. So the end customer dashboards and all. So to generate all those things, we do analyze this huge amount of data. So now to overcome that challenge, one of the solution to handle this kind of big data and to process it and all, one of the solution we do have is Hadoop. So Hadoop is in play like to storing the big data and processing almost from 2 decades. Just after the year 2000, once this big data word came up, the next thing started building is like Hadoop. So it's the Google who really took a step forward in innovating a lot within the Hadoop area. So now let's just understand what exactly this Hadoop is. So to get into understanding for Hadoop, let's see. I'm not like more of a slides person. So Hadoop is actually a framework. So whenever we say something to be a framework, it is built using some programming language. Still, you need to write your own program to get things done. So that means Hadoop is completely built using Java. But don't worry, it's not necessarily like we should write only in Java to work with Hadoop. So we can simply use SQL and Python to get things done. So nothing to worry. So Hadoop is a framework that does distributed processing. So let's just understand what is this distributed processing. So now listen carefully and give me an answer, guys. I hope every one of you answers. So let's say we have 100 books and we need to place them in a rack. Okay. It takes 10 minutes to me. I employed 5 people to do the same job. How much time it would take to complete the work? If you want me to say the question again, just ask me. So I'm saying, I'll say one more time. Listen and try to answer. Okay. I have 100 books. I need to place them in a rack. Okay. It takes 10 minutes to me. I employed 5 people to do the same job. How much time it would take? No guesses? It's a simple question, right? No one want to answer that? Okay, fine. Because this is a in a way intro session, it's okay. But if I ever take day-to-day class, it's like must that you guys should be talking to me and interacting to me. For today, it's fine. But if at all things move forward, so if anyone in my session, they should be talking. So it's simple. See, for me alone, if it takes 10 minutes, if I employed 5 people to do the same job, it would take 2 minutes. That simple, right? To complete the job. Until unless everyone works at the same time. See, if the person work one after the other, there is no point. That means it should like the parallel computation, we can consider it as. So the distributed processing is like we are distributing the work across the people. So just like that. So when we talk about distributed processing, it's like you have 100 GB of data that should be processed. So you can have 10 machines to process that 100 GB data. So instead of completing the work in 10 minutes, the processing job will be done in 1 minute itself. So in the example we just spoke about, we got an advantage that everyone got only piece of work. That means no machine is getting overloaded. And second thing is your processing time is decreased. So the work is done quickly. So that's about distributed processing. And what we are distributed processing, the big data, the large and complex data sets. So now, so where we are doing this processing on a cluster of machines. So cluster means group of machines connected by network. Okay. So group of machines connected by network is called as a cluster. And each machine in a cluster is called as node. Okay. So Hadoop is a framework which does the distributed processing of these big data sets on top of clusters. And how we are able to achieve that is like by some simple programming language. So this simple programming language is what we will learn as part of our training program, basically. So I hope this definition is clear for you guys. So let's have a quick look. So Apache Hadoop is a framework that allows for the distributed processing of large data sets across cluster of community computers. Community computers is nothing but like the machines are connected all together and working together on a single job using a simple programming model. and it is a open source data management. So when we say open source means the license is freely available generally. So some of the examples of your open source softwares are like Java is open source. Then again, the Google OS, the OS you have on your mobile is open source, right? So the licenses are freely available. That is one of the major reason. So in the distributed processing field, it's not just the Hadoop. We have other options also. But why Hadoop is so successful is that because of this reason, open source. And the second thing is scale out storage. So now when we talk about scale out storage, firstly we need to look into what a cluster is. So we just mentioned it's like group of machines connected by a network, right? So the group of machines will look like this. So this is a picture of Yahoo's Hadoop cluster. So here you can consider every blade as a node or a machine. So to imagine this, it's not necessarily like every project you work will have this many number of nodes. This is a huge cluster what I'm showing you. But in general, it can be just 20 nodes and 30 nodes. So each blade represents a server, basically. So to get more understanding like how this each node would look like and all, you can just go to YouTube and look into Google data center or Facebook data center videos. So they will give you a very good understanding like how a data center would look like and how a node exactly look like and how a admin maintain that. I always suggest in my first session to look into those videos to get a proper idea so that whenever we talk about cluster, you will be good like you'll feel comfortable imagining what a cluster is. But it's not the data engineer's duty to maintain that cluster to run it all the time. We are more of like we utilize the data that is present on that particular cluster and how to process that as a data engineer. But the thing is, Hadoop runs on the cluster. So that is the point. Now, so we are good with the Hadoop and the big data part. So this is like an introduction. Like as a data engineer, we'll be working a lot on Hadoop in some projects, and in some projects, the same Hadoop will be instead of Hadoop, they'll go with the cloud solutions. So either ways, we'll be looking as part of the program, both the Hadoop and the cloud thing, how it will be processed. So within Hadoop, we have like multiple tools. So when I say multiple tools, so let's say you want to store the data. So within Hadoop, so to store the data, we use something called HDFS. So HDFS is the storage layer. So only it stores the data. See, for example, if I ask you a Google Drive, okay, what all you can do with your Google Drive? You store the data. How means you just drop the data, right? It is just a storage thing. It is not like a processing. It will not give you like dashboards or something. It doesn't do the programming. It just stores the data. Just like that, your HDFS is just like a storage layer. On top of that, for processing, you have multiple options. So we just discussed like structured data, semi-structured and unstructured data, right? So based on what kind of data you are getting and what kind of processing you want, so we will sometimes we'll use MapReduce to process it, sometimes Spark to process it, or Hive, HBase. So these are all like various processing options we do have generally. And then we have something called yarn. So yarn is like, so here you have like a cluster. Let's say you have a 20 node cluster and you want to process some 10 GB of data. So out of the 20 nodes, so node is a machine, okay? So out of the 20 nodes, three machines are sufficient to process the 10 GB. Let's consider like that. So so now there should be a decision maker to choose out of that 20 machines, which three machines are going to work. So that job, that means the resource management, is done by Yarn. Okay. So this, whatever the tools I'm expressing here, like we are the HDFS, Yarn, MapReduce, Spark, HBase, Hive. So all these are like part of your content. So we'll be looking detailedly how HDFS works. We'll look detailedly how MapReduce works or what Yarn exactly does and Spark does. So we will go deep into every tool. So though we have so many other tools, so there is a stack of tools which are like must to be as a data engineer in real time. So once you learn such tools, even if some other new tools come up, you can easily understand and learn by yourself over the time. So that will be like part of your content. So now let's just understand what a data engineer does basically. S- So a data engineer most of the time deals with the definitely into the data analytics project. They'll be like cleaning and organizing the data, So most of the time, collecting the data and mining the data. So refining the data for the algorithms. So building some training data sets. So a data engineer will be working with different standards, like at times they will be in a machine learning project where the data being collected, cleaned, and sent will be to an algorithm. And at times they will be in BI projects where the data will be further utilized by the data analysts or the BI reporting people, BI team. So, or sometimes the data can be utilized for data scientists. So it can be for an straight away to algorithm, sometimes to a data scientist, or sometimes to a BI reporter, like that. So, but it depends on, sorry. So it depends on the project, how it is going to be, what all a data engineer will be doing. But what exactly they will be doing can be summarized into these points, like collecting, cleaning, and organizing data, so mining and refining. So all those things you can consider as the major activities what a data engineer does. So we all might have heard a lot what an ETL is, like extract, transform, and load the data. And so the data engineer closely does this process of extracting data from different sources and then transforming that data as per the requirement and then loading them into different destinations. So this process can be sometimes modified as ELT also. The data engineer deals with both of them. So a data engineer should be aware of various data formats, how these data flows, structures, and models, and they should be good with interacting with various stakeholders also. Okay. Now, so when we talk about an ETL process, so we'll be getting the data from various sources. Now, when I talk about the sources, let's say you have a retail store. So there is a transaction happening, purchase of items, and the items are maintained in the inventory, right? So there will be data associated with the inventory. There will be data associated with the purchase and within the store or online. So based on the kind of data or the business transaction that is happening, that data will be recorded into some tables in the backend to store the data. So those are the source of the data. So why we use specific databases to specific works, or how we deal, what is this data lake and all, will be covered as part of your content in very detail, why we do or how we do. So but as a data engineer, from those, so whatever the real time events, those will be stored into the databases from where the data is extracted and then landed into a data repository or a data lake you can consider. So where the data will be processed and then the data will be stored into the some destinations, like as we mentioned, it can be a algorithm, it can be the BI team, or it can be the data scientists, whoever it can be. So but the data engineer majorly deals with collecting, transforming, loading. So that is ETL process. So whereas, or it can be also be like collecting, that means the extraction or collection, and then transformations, and then loading. And then there will be like further procedure even after this. So there is, if you notice here, you have multiple stages and then activities at every stage, basically. So that's why we call it as a data pipeline, because the data is being undergoing multiple stages and phases here. Okay, so the majorly, so let's just look at this picture in more detail. So a data engineer will be collecting the raw data, processing it, and then storing here and there. See here, you could see some data scientists taking that same, the whatever the data that is modified and stored, that data is being used to train the algorithms and things. At the same time, the same data set can be also utilized by the data analyst to build the reports and all. So a data engineer is like very crucial, whether you take a AI project or a machine learning project or even a simple business intelligence projects. So to all these kind of projects, so the key is data engineer. Why? Because the data quality is very much important for any algorithm or a project to be successful. So the quality of data is very much matters, where the data engineer plays the key role. So now, earlier, everyone had their own data centers, basically. So when I say everyone, if you take any bank, Okay. So that bank has its own data center. Even now they are having. So, but when we talk about own data center, it involves a lot of maintenance. Like it can be networking, electricity, security, a lot of resources required, and all right. So to overcome such kind of more burden, so they people are moving to cloud, because in cloud someone else will be maintaining the data center. We will be paying them and will be taking whatever the resources we need. So that's why currently whatever the requirements we do have, we have, so we call these own data centers as on premises data centers. So whether it be on premises data center or cloud, the data engineer's job is to dealing with the data, like collecting, cleaning, doing, and all these things. So to deal with all these things, so we will be learning. So now we are getting into the what is the content of the program. It's like Hadoop, Spark, cloud computing, and data concepts will be like the major sections we'll have within our program. So under Hadoop, as discussed, we'll discuss about the storage with HDFS. So to work with HDFS, we need little bit of Linux, which you will be learning as part of the program. Okay, sorry. Yeah. So next. Then after that, so don't worry about Linux. It's like very bit like 15, 20 commands is what you need to learn. So it's not like anything heavy, and that will be covered as part of program. So MapReduce is something done with respect to Java. Having a basic programming knowledge is sufficient. In a day-to-day basis, you will not work on Java or anything, but we learn MapReduce how it works is like we just need that knowledge how it works, but not exactly how we develop the program and all. Java programming is not required. Then yarn. So MapReduce and yarn are not like very much a practical based, like where you will develop something, or these both are like more of the concept oriented. And after that, from here, everything what we do is hands on is like very much important. So we have Hive that deals with the structured data processing, and then we have Scoop is like, so we just discussed like the data engineer will get the data from some external data sources to data lake, right? The So to do such kind of jobs, so we need specific import export tools. That means to move the data we need some mechanisms. So Scoop is a mechanism which we use to move the data from external data sources to your data lake. And HBase is a NoSQL database category. So we'll look that in program in more detail, because that itself is a concept to be explained. And Uzi is a job scheduler. So let's say we were talking about moving the data from an external SQL DB to data lake, right? So daily after the bank is closed, like at 10 p.m., we'll be moving the data from the SQL DB to our data lake, or consider whatever the cluster we have. Okay. So now if I want to, so I wrote a Python program, let's say, to move the data from the SQL DB to cluster. So it's not like daily at 10 p.m. I will log in, I will play the program, and daily it is going to move the data. So that doesn't make sense. So instead, we will schedule that script. So we developed the Python script once, and then we'll schedule that script that it will auto trigger daily at 9 p.m. or 10 p.m. what are the time we do mention. So that is like job scheduling. So in within Hadoop, we have Uzi, it's a job scheduler. So once we are done with Hadoop, we'll get into the Spark. So within Spark, we will go in very detail like what is the Spark core elements and how the Spark SQL works. And then what are the different kinds of performance issues we do get in a day-to-day basis, and how do we do tuning. And then we'll get into what exactly Databricks. So within Spark, we have something like Apache Spark, which is like complete open source, and the Databricks Spark, which is like more of like a vendor oriented. So Databricks is like one of the vendor for Spark. So we'll see both of them. And then we'll get into what cloud computing is. We need certain fundamental concepts, whatever cloud it is, like it can be AWS, that means Amazon cloud, or Azure cloud, or Google cloud. Whatever cloud it is, we need certain fundamental concepts. Common, it is common to every cloud. And then we'll get into specific to AWS cloud. So whatever these services mentioned here are like most utilized in a data engineer role in a way. And then so we cover all these services as part of AWS and as part of Azure. So whatever uh, the elements we are covering here is more of like a data engineer oriented. So whenever you think about cloud has each cloud, let's say if you take AWS itself, it has more than 200 plus services. It's not just this 5 or 10 what it has, but to a data engineer these are the major things should be known. So apart from that, it's like a personal interest to what level you will go. And then we'll also discuss, like as part of the program, the more data specialized concepts like what are databases, data warehouses, and how these each things are different. So these data layers will give you a complete perspective of an end-to-end view of a project, how it would look like, and the pipelines and every other thing. So coming to the one of the major concern every time what students will have is like a lab, like what the hands-on you'll be getting. So I will be showing with the sample codes and with basic sample data sets. So we will also set up a lab for you based on your computer configuration. So we will download a file something like this. So that will give you almost a 95% similar environment to the real time. So you will set up the lab, so that is to the Hadoop. And coming to the cloud, you can create free cloud accounts and you can try the hands-on. I'll be guiding you through the entire process. Then again, we have we'll be sharing the reference documents, and on a day-to-day basis in my sessions, talking is must. So whether it be you talk or you do message, but answering to the question and being interactive is important because you are the one who need to face the interviews, right? So if you hesitate to interact with me, how you gonna take up an interview or deal with a day-to-day job basis? So you should feel free to interact within the sessions. That will build your both interpersonal and communicational skills. And then session recordings will be available by the last week. So this is a total 6 week program with 50 hours. So where your last week, within your last week, we can have like a resume reviews, so individual resume review sessions. And then the interview guidance. When I talk about interview guidance, so day to day when I take up any module, so within the teaching part itself you will get the on spot interview points, like this can be asked in your interview, or this is how you should answer within interview. And also if you could make note of them, it's not like you will get a separate interview session. So yeah, though we have such kind of session, so my major point is topic to topic you'll get on spot the important points or the points where you need to stress or more focused. So, and when we say the program certificates granted on demand, as I mentioned, you should be interactive within the session. At the same time, you will have certain expectations. So see, data engineering is not something which I just teach you, listen and you'll get it. So I can make you understand what it is. So I will drive you through the path, but you are the one who need to dive deep into the topics. You should sit and practice. SQL and Python are prerequisites for to become a data engineer. So if you are not familiar with them, so try to get touch base with me, so that we can plan for a separate sessions for them, or I can guide you. So we can plan accordingly based on what the knowledge you have, both for Python and SQL. And but those two are like must a prerequisite for a data engineer. And once you get into the program on day-to-day basis, so there will be certain topics where you read the topic to get the terminology. See, whenever you are talking about a concept, what will define that you are good at it? The terminology, what are the words you are using? So you will learn a lot of new words throughout the program. So um, you should utilize all those skills. And also I will give you certain small assignments and tasks, so you make sure you solve such things. So if you do your assignments well and if you are interactive within the program, so within that 2 months if you can satisfy, like you're doing good, uh, then the certificates will be given. It's not like whoever attend they'll be getting, but you should really do some performance, like both with your. So if you didn't understand, if you're open to ask, that is a biggest qualification I would say to get a certificate. So these are my details. Feel free to message or WhatsApp me on this number, or you can email me always, and you can connect with me on LinkedIn. So right now we have like 5 more minutes. You guys feel free to ask the any questions that you have. Tanmay, we just done with the session. The I can share the recording with you guys. Um, you can contact for further more questions. But right now, any questions for me like Hadoop, Spark, and data engineering? So feel free to
Yes,
ask the questions. Yeah, please go on.
yes, Sweta.
I'm not.
Sweta, I want to ask. Yes,
Mm,
I want to ask here. We
mm.
schedule job schedule we can manage in school.
Uh, so job schedule we are managing
In the school language. You
in
said that you
SQL.
before few. Yes, yes.
No,
Few minutes ago, you
it's
said that we can
yeah.
schedule only Python.
Oh, no, no, no. I said as an example, I wrote a Python code. It's not like Python or SQL. Any program
Yeah.
or anything, whatever it is, whatever we discussed, you can schedule anything,
Okay.
any program. And within
Okay.
job schedulers, Uzi is one of that you have within Hadoop. But I have a plan that I will introduce you to Airflow is also. Airflow has 30 to 40% of market in job scheduling. So there are like you have like Stone Branch, Airflow, and Control M. So all these are job scheduling tools. So there are like many other. If you go to cloud, you have like AWS Batch and other things. Even Glue, Databricks, everyone have a job scheduling facility. Like how we schedule our meetings, in the same way, in a way, we will give the
Yes.
programming script and we schedule them. Some scripts run for every 30 minutes, 15 minutes when you go to a real world. So we do such kind of things. So, but we will be learning specifically Uzi in detail, and also I'll also give you an overview like how to work with Airflow, and I'll try to give you an idea like and also Databricks scheduling. So, so
Okay.
certain
Okay.
schedulers
That's
also
great.
will be covered as part of the program. Yeah.
Yes. Okay.
Can I know
Thank you.
your name if you don't mind?
Rina.
Rina. Oh, okay, okay. Yeah.
Yes. Yes. Yesterday I was connected with you.
Yeah, I got it. I understood. Thank you, Rina.
Okay.
Yeah.
Okay. Thank.
And any more questions, guys? Feel free to ask.
Yeah, hi, this is Mahadev here.
Yeah, yeah. Go on.
Yeah. So actually, I'm on the business intelligence side, and I deal with the data engineers, data scientists, data directors. Okay,
Mhm.
so I drive on
Okay.
the business decision side. So my interest is in the visualization and creating the design systems and the graphs which can help the management to take the decision. So in
Correct.
this case I work with the RPA, the data lakes, the Domo BI, all these tools are there, guys are
Mm,
supporting us. So
mm.
for me, because this is totally more on the data engineering side, so
Yeah.
how I can for my interest is in the Power BI or that graphical interface, but behind I work as a data and process expert, okay, in the China almost 7 years, and I was
Okay.
dealing with the SAP, ERP, PLM, MES system. All the data I was analyzing actually and making the decision what should
Uh,
be key decision. So, but
yeah.
how to visualize that one? Okay, that visualization dashboard I want to create anyhow in any system, doesn't matter which tool. So, how you will guide me in this case? So, this is what my expectation actually.
See, data visualization for that we always have the Power BI engineers or example I'm saying like or BI engineers, data analysts. So those job roles deal more of with the data visualization. So to create a
Okay.
data visualization, firstly you need to have a proper data set. See, you need to project a upcoming month sales. So
Mhm,
if you take the data that is like previous year, that doesn't make sense. But if you take the data in last quarter, that will make sense like to predict the upcoming sales, right?
mhm.
The quality
True.
of the data. So what all data should be involved and how that data should be. So someone should get ready all that data. Then only you can pull
Correct.
that report into your visualization, right? So the one
That's right.
who collects, cleans, get ready the data is like data engineer. So
Okay.
be after that, whoever takes the data, analyzes, builds the reports, they are like data analysts or BI engineers, more of.
Mhm. Understood. Yeah.
So it's
Okay.
like two different roles. So for that, you should focus more on like visualization tools. Um, so data engineering will be like a different responsibility. But in certain organizations where it is like a mid-level company or a startup kind of organizations, data
Mhm.
engineers itself creates the reports also. So it
True. True.
entirely
Understood.
depends on the organization. But at that point of time, the data engineer should go a little more beyond and should learn the Power BI and the other one is Tableau. Yeah. So the these two are like some of the familiar visualization tools. Apart from that, we have ClickSense and other D3, many other visualization tools.
Yeah,
So,
to
but
understand. I think this is really good one. What you mentioned, this data
mm,
engineering is a very key because this is how it stores the
yeah,
data in the way it has to take out for the
so
rest of the
that's the
job.
reason. Like going forward, also, we know that it's like data, AI, everything
Mhm.
is like increasing a lot, right? So
Mhm.
every AI project, every machine learning project, or every advancement we see in technology is very much dependent on data. So where data engineers are so key to create them. So that's why there is like a good future for these kind of job roles. And once you get into the data engineering, you will get a very good view how to deal with data. And if you take your own interest and if you further learn little more programming and all, you have a good scope to become data scientist or data analyst. You can go to any level like after
Got
that.
it.
It is like a very good base to have.
And
Yeah.
this is a foundation data engineering. That's true. Okay, understood.
More than foundation, we can call it like the crucial phase in a data
Correct,
analytics
correct.
project because every phase
Agree.
is equally important here. Yeah.
Yeah, yeah, true.
Yeah.
Understood. Yeah. Thank you for this. Yeah.
Yeah. Yeah. Thank you,
And
guys.
one more thing you mentioned that
Yeah.
prerequisite. For example, prerequisite.
SQL
For example, you mentioned the
and
Python
Python.
or the SQL. You must know it.
Yeah.
So it's
Yeah.
better to read it before coming to the next session or something, right? So that how the terminologies, understanding on those
Uh,
things. Or no
No, no,
need.
no. It's not like you should learn it right away. So as the program progresses, I'll be giving you points like so for tomorrow's session we would need it and all. So right away it's not required. So you'll have a
Okay.
1 week of time. I'll give you a list of topics what need to be covered or where you can refer. So I can give some suggestions and all. So depending on people's request, I'll give whatever the guidance I should give
Understood.
to cover them. That wouldn't be a
Sure, sure.
challenge.
That
Like
would be great.
if you are committed,
Mm.
it's not a challenge to learn SQL and Python. Even within Python, you have so many libraries, not everything is required. So there is a set
Mhm.
of Python topics which needed for Spark and data engineering. So I'll
Sure.
give a list of them. That wouldn't be a problem.
Got it. Yeah. Okay. Yeah. Thank you.
Yeah. Uh, if any questions, please ask, or else you guys are good to leave. I hope you have this, you received this document, the content document. So in that you have my contact and details. So I'll be starting a batch on Thursday, this Thursday. So if you guys, if anyone are serious or willing to get into, please get in touch for any questions or queries. So we can further discuss like how things would work. So that's from my side for today, guys. If any questions, please ask, or else you guys are good to leave. Happy Sunday. Thanks for joining.
Yeah. Thank you for this valuable presentation and the session. Thank you.
Thank you. You'll get the recording. Thank you.
Thank you, Srilata.
Yeah, thank you, everyone. Bye.